do you implement ML and AI projects in weeks instead of months? How do you drive adoption among extremely safety-conscious stakeholders where mistakes can be catastrophic? And what does responsible AI have to do with all of this? Today, we are going to find out, and I am joined by Dr. Alex Manasson, who leads data science for the Americas at International Flavors and Fragrances. You might not have heard of them, but I can pretty much guarantee that you've either been eating or wearing one of those products, if not in the last month, probably within even the last hour or the last day. Alex, thank you very much for joining us.
Thank you, Kjell. It's a pleasure to be here.
Well, Alex, could you set the stage for us? What does data science look like at IFF? How is it similar or different to what it would look like at any other organization?
Yeah, sure. It's a great question because most of the companies that you hear about, the AI companies, they're really more in the consumer space, maybe insurance space, banking space. For manufacturing, we're still on the upswing, let's say, of converting to manufacturing 4.0 and utilizing AI in daily situations. But we at IFF, when we work with AI, we have multiple divisions. We have R&D, which has their own applications. Obviously, generative AI would be clearly cool thing to design new flavors, design new fragrances. So lends to itself. But my team is within operations. We're concerned a lot with manufacturing, supply chain, procurement. So this is where AI has been kind of catching up to, let's say, what we call mainstream companies, right? Where they're positioned right now. So we're developing a lot of these new products that are very targeted for some of the solutions that are different, let's say, from the consumer fields of consumer domain. So we're a little bit different in that regard.
Well, it sounds like you have a lot more demanding, time-pressed stakeholders. So versus on a research project where, it can take a couple of months and it's fine. If it doesn't work out, there's no big loss. But it sounds like in your case, it's no, you really have to deliver for these stakeholders, because if you don't on the first time round, the likelihood that they're going to come back the next time round isn't quite so high. And presumably they're looking for results in a much shorter, quicker time horizon, or am I exaggerating?
No, it's absolutely true. So the solutions that we develop are all for internal customers, and sometimes this is a very small user base, but still very significant returns. And yes, it's true. It's a very dynamic workplace. Things happen very fast. Priorities change very fast. It could be different products. It could be if we take too long to develop, let's say, a product for somebody, a digital product or analytical product, they will move on. They will try to do things by hand. They will find a workaround. They will lose interest very quickly. So the challenges still can be very, very complex. And it's true that some projects can take years to fully develop from zero to final, fully blown products. So what we try to do to expedite the processes, we try to break it up into smaller pieces, smaller digestible chunks, targeting very specific problems. So when we do root cause analysis we're not really delivering solutions. We're solving problems. We're not delivering products. The product is a byproduct of our work on solving a problem for end users. So if we can split up a complex problem into smaller parts and address one part at a time, it helps us in multiple ways. One is we started delivering value right away instead of waiting for a year to have a full application delivered. The second part was continue to build trust. So our end users, once they see the results, once we wow them with what AI is capable for, machine learning is capable for, our analytics are capable they start building us. They start looking for more, because we see that we make their life easier, right? That's our job, to make somebody else's life easy, to support them in some way. So they come to us. So, what you did is great, but you know what? Instead of waiting for this big application, I also want you to solve another problem. Can you do that for me? So we start delivering. We get into this virtuous cycle where we deliver something very quick. And it could be, not necessarily fully productionalized. It could be a Jupyter notebook that somebody runs once a month, or a couple of weeks. Or it could be we generate one time a spreadsheet that does a job that helps them do their job 20, 30 times faster than they would have done otherwise. And they would go with this solution and say, you know what, this is good enough. don't worry about the rest of it. I have another problem for you. Can you solve it for me? Right. So we get into this cycle of delivering quick solutions and building one on top of another. And when we focus on one area and we do several projects in this, they naturally build up to a full application with different features and potentially multiple models or model improvements where model continues to develop as we build up applications, as we build up functionalities.
Well, I mean, it sounds like there are sort of interacting, self-reinforcing or reinforcing components to what you're describing here. It's the delivering value in stages means that you can keep your stakeholder more engaged because you're not going for long periods of time without them seeing results. And at the same time, by keeping them engaged, that also builds trust because they're now seeing the value, obviously, but they're also being pulled into the project in a much more direct fashion than, again, if you're going between long cycles. But it sounds like there is for lack of a better term, scrappiness to this. It doesn't have to look pretty as long as it solves the problem that's at hand. The end user, as you say, doesn't mind if it's a spreadsheet. They don't mind if it's presumably in a very simple application. It doesn't have to have bells and whistles and necessarily have a lot of end user design features on it because they're willing to work around that. These are tech savvy individuals who manage complex processes. If they have to jump a couple of hoops in order to get this to work in the way that they want to do it, it sounds like they're perfectly willing to do that.
Absolutely. Yes, absolutely. And then there is an expectation. We don't leave our end users. So if they say, yeah, we want this, better functionality, more prettier or something easier, obviously we work with them. And to be frank, I think one of the biggest reasons for our success is because we work so closely with our end users on solving very specific problems. Uh, our end users, the people who are delivering these products for, they are part of the development team. So when we have our sprints or we have our meetings or biweekly reports, they are part of the team that was not only on the receiving end of the progress, they participated in that progress by providing feedback for what we do or providing domain expertise, explaining some of the things like how we can generate better features for our models. So they are very, very much integrated into the development team. They are really part of it. And I think it's a key to our success internally. I think all projects where we've been very successful were the ones where we worked very, very closely with end users. And there were some where we had very sophisticated models that had a lot of potential, but the end users were not consulted early enough. The adoption was a huge struggle.
Oh, yes. I mean, I struggle to think of any company or team that I've spoken with who hasn't been really striving to be as close to the end users as possible and to work closely with them. But it's an entirely different story in terms of actually achieving that. I'm wondering whether or not there's actually something which is different about your end users, that they are more data savvy and technically savvy than you would see and if you were just to take a random use case. And so because they're more data savvy, because they live and breathe with this, it is easier for them to participate. It's easier for them to understand what's going on. It's easier for them to actually learn, and they probably want to learn about these methods in a way that, well, your average business user, say from accounting or from legal or a doctor, would love to conceptually, but they're not actually used to working with data and familiar with the ways in which can go wrong. Or again, is that not the case? And actually, no, we have to bring them along on the education side. And, they come from a whole range of different backgrounds. And occasionally, yes, we get lucky and they actually really understand this already. But for plenty of these other ones, we got to bring them along for the ride.
I think it's the latter. It's a mixture. So we do have, we work with analysts very often within their domains, like analysts within procurement, analysts within supply chain. So they're very used to working with data sets and numbers and doing analytics. So they are familiar. But we sometimes, and also on the other hand, for manufacturing specifically, we work with process engineers if we're building models for, let's say, predictive process control, for chemical process control, right? They are also familiar with data, right? Not necessarily. They might not. Some might actually know a little bit of machine learning. Some might not, but they are familiar with data. But then on the other hand, we work on some use cases where people have almost no interactions with data at all. I mean, you're a regular person like off the street, so like operators of the equipment which know their chemical process, but they don't deal with a lot of data, or they don't even use. So we have we worked on some use cases where people were still using pen and paper to record stuff, right? So we have a breadth, a wide range of users, and very often, even the ones who are data more or less savvy, we still have to educate them. And this is where this iterative process of doing small things for them first, it really helps because they do start understanding. And uh, as an example, one of the first use cases when I started at IFF, we built an entity resolution system, which was very successful because we worked so closely with our with our procurement partners. And the process took a while, and part of the process was for the procurement team to label the data. Labeling for classification. So we successfully completed the project, and it was in production for years. And then they came back to us years later and said, you know what? We remember what you did for us before. Can you do something similar, but in a different area? So we kind of already finished that. The project was done, we moved on, and then they came back to us and they said, "We have this opportunity. You come help."
Well, I mean, that is the surest form of a measure of success is when they come
Yeah,
back and they want you to do it and they want you to do it again.
yeah,
Hmm.
yeah.
Could you tell us a little bit more about that use case? So this is one where you're trying to you're making it easier to go between different procurement contracts because you are able to extract those entities, and now between if you're searching for a particular contract, you're now able to get the full list of contracts that would actually have that entity.
Yeah,
Or what are the ways that they use that data?
yeah. We have, as a company, we've over the years we have grown a lot, and some of it was through mergers and acquisitions. And every company that we have merged with and acquired, they had their own systems for maintaining like vendor information or customer information, obviously. So we have a lot of these systems floating around legacy. And while there are consolidation efforts to bring it all together, you have to harmonize. So you have to resolve which entities across all of these databases really match. And on top of that, there is a complexity because match means different things to different people. So a person from finance might define a definition of match for them would be different from a person from procurement or somebody else. So the system that we built was for specifically for procurement to try to recognize on multiple levels. So not just to recognize entities, but also hierarchy of these entities, because companies have divisions that might have different legal entities, and they might have subsidiaries and so on. So we also built a hierarchy for them. So we built a solution that would harmonize across all of our databases in like MDM pass-through style. So we basically build a unique set of new IDs. We didn't change anything in the original systems, but we built a new unique set of IDs that would identify, point all the records to the same, that's supposed to be in the same entity to the same entity. And it's being used for all reporting. So reporting before had to be aggregated across multiple systems. You can imagine like 40 different spreadsheets. But now you'd pull one, and instead of using all the IDs, you would do all the analytics on the new IDs, right? So this is kind of the usage. This was the
Hmm.
initial usage. This was entity resolution. It was an very interesting project, in part because the data quality was so poor. It was a lot more complicated than it should have been, right? If we had perfect records. So there were lots of problems with things like names misspelled and addresses misspelled, and wrong things being ended up in the wrong columns. So there was a lot of work being done, not just cleaning, but we had to build more sophisticated models that would kind of combine, aggregate all the potential similarity scores, accounting for the things that there could be really bad mistakes in there, and try to build a resolution system. So it was a classification system first that would classify whether a pair of records are how similar they are, whether they are matched or not, according to our end user. And for finance, it would be a different model. And then after that, on top of that, there was a clustering algorithm that would group all of these dependent on their distances. So you would have groups of the entities, right, of the records that would belong to the same entity. And we've at first it started just as I said, it was a Jupyter notebook that we would run once in a while on a smaller subset of data, and we have a lot of records. It was hundreds of thousands of records. So going by hand and doing this is impossible. It takes years. They actually started doing that a decade ago. They tried to do this manually. It took them several years where they did in a small chunk of data, and they stopped there because it was impossible. So
Yeah.
yeah,
Several decades ago, I used to work with patent data, and I was always stunned by the number of inventors who don't know how to spell the city that they live in, and running into the same challenges. Um, I guess I'm curious in terms of the value that comes from this, in the sense of, I mean, I can imagine that being able to do this more effectively enables you to go in and have a better overview of sourcing and recognize when actually this is going to the same suppliers and be able to negotiate better prices from them, for example, or be able to identify when you've got supply chain risks because it's too consolidated on a particular supplier. But it sounds like there's also another element of this, which is just well, somebody had to do this manually as part of ongoing reporting previously, and it was a pain, and the data was poor, and all of those kind of things. So there's a cost and efficiency element to going in after a use case like this as well. Was it
yeah.
more on one side or the other?
It's actually both. So the need, our actual original problem was that there was no visibility, exactly what you said, single sourcing or too many different sources for the same material, right? Consolidation of vendor base, really having an understanding what your vendor base is like, and it was very challenging. And so analysts were struggling with it. You would have small subsections, right? Little domains, so somebody would be focused on just one group of vendors because that's already overwhelming. But overall picture was very difficult to put, and even for the smaller, subsets of this data, it was still too big of a challenge for an individual to be able to do this by hand. It took one person, like I said, we had maybe ended up harmonizing maybe 1,000 different records, where we're in hundreds, closer to more like closer to 500,000 of different records that we have, and they managed to deal with just 1,000. So clearly, that manually that effort would not ever succeed. It will take years and years for many people. So automation was a big part of it. That was the process. So we tried to automate the process, but the goal was not necessarily build 100%. So we could have continued to improve, but what the end users really needed is they needed help with recommendations, or at least initially, right? Because even though we build like internally, our internal test results for the models were higher than 90%, 93% accuracy, which is really high. A typical MDM is around 70% accurate. So we were, significantly better, but still it requires validation because some important decisions are being made in that. So the validation was by hand. When we built the first prototype of the system, the model itself was already built, but how do you produce the output? So instead of having an application, instead of putting in the database, it was a spreadsheet. You would send somebody a spreadsheet with recommendations, and they can very easy, and you would design it in such a way that it has all the relevant information for the end user to be able to validate very quickly. Right. So that was the beauty. That was the part that's not ML related, not AI related, but how do you produce your output for the end user is so important, because it made it useful for them rather than you just delivered a great model that works in principle. You delivered a solution that works for this specific end user.
At the end of the day, it's always the right information to the right person at the right time in the right format that they can actually take the right action off of it. And
Yeah.
it's amazing how that was true, I don't know, decades and decades ago, and it still is true today, and we still struggle with it.
Yeah.
I guess I'm always curious because when I was an industry analyst at Forrester, I was always surprised at how few success stories I saw in the manufacturing space. There would be some, but it wasn't anywhere near as much as I was seeing in other horizontals and other verticals. And that always struck me as weird. I mean, this is a data-rich environment. There are ways in which data is generated all over the place. It should be a target-rich environment as well. But I've always speculated as to why I don't hear more success stories. And I was wondering whether or not one of them is the culture side of things. This is, after all, a place which has been, not dominated is the right word. It's been led by operations research engineers or operations engineers who are trained in Six Sigma methodologies, which are looking at at faults, trying to detect faults that are a tiny, tiny fraction of what we would be comfortable with when it comes to predictive accuracy on a machine learning model. So I guess I'm wondering whether or not is there a cultural challenge in terms of bridging that mindset of, well, no, you shouldn't be thinking Six Sigma, you should be thinking, how can I improve on what our existing process, on what our existing decision-making process is? Or is it more really on the data side that, yes, it's a data-rich environment, data is generated, but it's so messy, it's so difficult to consolidate, harmonize, and work with that there's actually a fairly big barrier to entry in terms of being able to go in and tackle that low-hanging fruit.
I think it's more of the second. In terms of a culture, it's true. Manufacturing, especially in some industry like chemical, pharmaceuticals, semiconductor, and semiconductor is probably one of the more stringent ones. Surprisingly, I think they're more stringent than pharma. Uh, because I think Six Sigma came more from there, right? One fault per million. But the culture of really paying attention to details, recording everything, being very data savvy, it does exist. But it's on the other hand, it becomes a hindrance to machine learning kind of projects because the question is, well, we already have statistical process control. Why are you bothering with predictive process control? Like why is there a need? And frankly, the honest answer is you're right. We should not jump straight from no process control whatsoever, or like a set of conditions that you always run but you don't pay attention to, directly to predictive modeling. It doesn't make any sense because even if you did have a really good model, which is extremely challenging, I'll get into the details a little bit later, even if you do that, if your operations are not used to operating in the best of the lean Six Sigma, right, really statistical process control, what's going to change their mind if you have a predictive model for them, unless you have a willing to close the loop completely and take the operators out of the picture, which is not going to happen for a long time. I mean, we all know about the story of the self-driving cars, right? It was always around the corner, and I honestly believe that they're very close because in vast majority of cases, you would make the right decision. But it's the problem with those outliers that the consequences are so bad that you just cannot allow it without human intervention, right? So this is where the gap is that the fact that this one small, the risk of critical failure, catastrophic failure, same for chemical process control. For us, if we have a predictive model in a closed loop, so it actually controls the equipment, and you have a prediction that can lead to catastrophic results, you literally could, blow up the building, right?
Mm.
And hopefully that doesn't happen. So that's why I see human in the loop being there for a long, long time. You have to build lots and lots of trust to be able to take the human out of the loop.
Yes.
Um,
Well, it sounds, is there, it's also possible to run those statistical control process methods in parallel to your machine learning model so that you can get a second opinion, another form of reliability or another form of control on this, in addition to presumably also having a human in the loop. So now you have a, additional levels of redundancy and oversight on what is
right.
happening.
And this is kind of what we do, but the resistance again, like what's the value? If we already have something that's pretty good, but so the value comes in two places. One is if you already have a really good statistical process control in place and you have good operations to execute in this process control. The next part is what do you do if you want to squeeze that 2 extra% out of the yield? And this is where statistical process control is too limited. So then you would have to go for something more advanced. And in those cases, which are not as common as you would think, so in those cases, you would probably have enough data, very good data, to tell you to allow you to build a good predictive model. The problem is with majority of the use cases, as you mentioned, we do collect enormous amounts of information. Devices, we can have thousands of the devices on a system on a reactor, and you would generate data every, I don't know, 50, 10 milliseconds a data point for each one of these sensors. So that's a lot of data. But the problem is there's all other kinds of data that is not necessarily being logged, for example, or connected very well, because the systems, even the simplest chemical process is still incredibly complex in terms of what's happening. You don't know, you have to connect everything happens to upstream. If there is an operator, you need to understand why did they just slow down the process today versus yesterday, and it could be because they are too tired, or they want to time it so the second shift is going to take over part of their job and they're not going to do it. It's not logged anywhere. And these are silly examples, of course, but you can imagine there is a lot of additional information out there that's outside of the sensors that's not being captured. So what happens with the sensor data, even though you have tons and tons of it, when you try to do a predictive model and then the data is too noisy in terms of you do not have some of the signals captured. So what you believe are signals in reality is just noise, because we have incomplete data sets. So we're not capturing everything that we need to be able to represent the physical reality of what was happening in the reactor. That's one of the big challenges in the manufacturing space because of so much complexity and every little detail matters.
Is that something that you find that you're able to tackle in the project, so that there is a component of a lot of these projects which is to go out and find and capture additional data or identify other places where that data which has signal has existed, but either hasn't, as you say, hasn't been logged, it's been thrown away, or it just wasn't visible, but was there? Or does it tend to be, no, we kind of have to work with the data that we have, and yes, we can explore for it, but the ability to change the data collection process, that bit can be it's very difficult in any organization. I guess I'm curious whether or not it's any easier on the manufacturing side.
Still hard, but again, if we take things from the beginning of project, let's just say that we're going to a plant and we want to improve a specific process. Typically, what happens is we do a lot of exploratory analysis on this, and some of the insights could be used right away. It doesn't have to be in this. We could use machine learning models, for example, to understand feature importances for things like that, right? Or statistical methods to understand feature importance, like what is important. We can deliver that fairly quickly. So the changes on the floor can happen without us having to have a fully blown predictive model. Like our predictive model we might not, with the data set that we have, we might never be able to get a high accuracy enough model to be fully useful. But we do see some trends that, this particular knob is really critical to the process, and we observe that when the process goes well, this knob is at this setting, at setting A, and if something goes bad, at setting B, right? So that's right away. That's very quick return. After that, we go back to Six Sigma and say, okay, let's do design of experiments. We don't have the right data. Let's generate it in a controlled way. So we typically, in the last couple of years, we started doing this after initial analysis, when we realized that we can't really do much. We start doing design of experiments so we can collect the data to be able to build, to generate afterwards decent enough predictive models. The last resort is if we say, you know what, this is too difficult, but can we still have, besides giving you more optimal set points from our initial analysis, maybe we can tell you, is it going to be helpful to you if we tell you, to the operator or for process engineer, if we tell you whether the process is going in the right direction or in the wrong direction with a given set of what's happening right now in the equipment. That's a classification. That's a much easier problem to solve than a regression when you have to know exactly what value needs to be for the process control, right? So we try to still, even if we can't find the full solution that the end user is looking for, we still try to find partial solutions. And when we do that, it again goes back to building trust. So when we leave a plant and we say, okay, we're giving you some model right now, start collecting this data and collect it for a year or for 6 months. We'll come back and we'll do something better for you after, because right now we just cannot do anything more. And there is a lot more willingness from our plants, from our operators, process engineers, to put the extra time to record the data, to do additional design of experiments. It's a lot of it is relationships, with our end users, not just machine learning, not just data itself. It's relationships.
Well, I mean, I'm struck by the fact that it's very popular these days to throw out the word digital twin, and was in Jensen's keynote over at NVIDIA GTC over and over and over again. And that sounds absolutely wonderful. And it also sounds like a boatload of time, effort, and investment to go in and create something that's going to be a realistic simulation or facsimile of an existing process. I mean, if it was going to happen anywhere, I would assume it would happen in manufacturing. But I'm imagining that you rarely have that luxury. And instead, this is more about, well, so what can we do in terms of simulating a machine, simulating a process, and doing that kind of quickly and generating the data that way, versus thinking of something which is a more high fidelity digital twin? Or no, is it actually possible to go in and create a realistic enough simulation of a particular process that we can then leverage the data from that in order to do interesting things and potentially train models off of?
Yeah, it's a very, very interesting question, and there is no there is no easy direct answer to that because it's in reality it's both. So digital twins for complex chemical processes are very complicated to build, especially if you're just going to try to rely on machine learning. Typically, what we see is that first principles trump in performance. It's pure machine learning. We started looking into things like physics informed solutions. So it's combination of first principles and machine learning, but it's still a challenge. And the reason why, because of the complexity. I mean, yeah, like I said, even the simplest process could have thousands of sensors, and usually it's not just one process. It feeds into a line, and line contains multiple processes, so they're all connected to each other. One feeds into another, and so on. So digital twins do exist. The problem that we've encountered, it takes a really long time to build, to collect all of the data, to really build an application. So if we find that the production line is really important, and we really need to squeeze out the as much as we can out of it in terms of the yield or throughput, it would be worthwhile to do that. But it's very often it's not low enough hanging fruit. There are other things that we can do much quicker that would give us immediate return, and a pretty significant return, because we're not quite there yet. With this said, there are out there the third-party digital twin solutions that we have been using. Funny enough, in the end, a lot of them still rely on first principles, and maybe there are neural networks somewhere in there, but in the end, it's always linear regression.
Well, I mean, linear regression, you can do amazing things with it, and it always has that benefit of being very explainable to an end user. And yes, you might have to get really creative in terms of interactions and other things like that if you want to get to map or to replicate or identify very complex patterns. But eventually you can. But so is the regression models largely because of the explainability, or are there other or the fact that it's time series data, or are there other things that make it still the workhorse?
Explainability is a very big part of it, because imagine a black box solution. Let's say you have a very accurate black box solution, but what you really need is not a black box solution. You need to know what needs to be changed, what parameter needs to be changed, and by how much and why. Even though there have been advances in explainability, right, of neural networks for sure, it's still not as simple to explain to the operator over the shot plot versus I have a coefficient of a linear regression, right? And this is why you need to increase this by 1.5 times and not 3 times, right? So yes, explainability is a very, very big part of it.
Well, it almost sounds like it's not explainability, but actionability. It's the explainability tells you what you should do about it. Identifying that there's a problem with it, great. You've told, it's sort of like had a warning that the risk to the world safety is very high. Great. So what do I do other than just be very anxious and nervous about this, and maybe buy gold? And sounds like a similar thing
both.
here.
Yeah, it's absolutely. It's both. It's both. Yeah, actionability for sure, but also explainability. So, like I said, we don't have any closed. We're not ready. I don't think industry-wise. I think there are very few solutions. I mean, I could be wrong, but I very doubt that there are many very closed loops, like fully closed loop solutions with ML products for manufacturing just yet. Maybe in some point in the future. So if you have a human in the loop, the human in the end has to make a decision. So that if they don't understand why you recommended for them to proceed in a certain way, it's very unlikely they're going to make that. They're going to say, you know what, who are you? Especially people who are not familiar with machine learning or even statistics. There's little trust. So it has to be easily explainable, and obviously actionable, as we mentioned, right? So not just that I know that something is going to happen, like what do I do about it, right? And linear regressions are very easy to work with for both explainability and actionability, because you know exactly what needs to be turned and you know exactly why.
Oh, indeed. Well, it sounds like there are a bunch of different things that are all happening simultaneously. So when we're in terms of being able to deliver value quickly or being able to drive trust, but also be able to minimize risk. It sounds like the same thing that you would be doing in order to drive value quickly. For example, doing this with human in the loop and augmenting an existing decision, delivering value in stages is exactly the same thing that you would do in order to drive trust, which would also be exactly the same thing that you would do in order to mitigate a lot of risks. So it sounds like, well, these it's not an either or here. It's not an either I can deliver value quickly or I can build trust or I can mitigate risk. It's the, well, I have to do all three of those simultaneously or I'm not going to be able to do any of them. Or is that is that true, or is it the well, it depends on the project. Some of them, we don't have to worry, or sometimes they can be in conflict and sometimes you need all three.
I think it's a very astute point. It is all three, and you have to, because you have to build applications not just for high performance but for their adaptability, right? So you always have to have the trust, and you do have to deliver it fast because it's not going to be adapted. That ship has sailed, right? That they would say, it's too late. I'm not. This is not a problem for me anymore. I'm already finished by hand, right? For a lot of things. So the I think naturally for us, because we have all these three kind of requirements in general, the way we work, the way that we try to split up the problem, the way that we focus on the problem rather than the solution. And for us, AI, machine learning, analytics, it doesn't really matter. It's a tool in a toolbox because we're solving a specific problem, right? So we are very problem focused. Um, and working with the customer and always addressing their needs and always trying to build their trust and having them engage in our team, that flew naturally out of our previous mistakes, where we did build in several years back, we built great optimization for like capacity margin optimization tool. It was great. It was a very awesome model. The problem is this is not what the end user really asks for. And even though they could use it, it took us a year to try to convince them that yes, you could use it. It's really useful to you. But in the end, we had to rebuild everything almost from scratch. I mean, the model still sits there by itself. It waits to be plugged in into the rest of the work stream. But because we approached it backwards, starting from a great model that somebody higher up said, you know what, this would be really great if we had a model for this. And we did it. And it was pretty good. But the end user who had to use this model said, well, I don't know what to do with this, right? So we learned our lesson. And this is why we started focusing on interaction with the user, on building trust with the user, on addressing their needs. We put in customer first. You hear it everywhere: customer first. But it really helps when you design a solution for the customer. And in this case, we're a little bit lucky because we're building for internal customers, and our user base is small. So we know who to build. We don't have the problems that you have this general population that you're trying to build an AI tools platform for. It's much harder to address everybody else's needs because the needs vary so much. For us, it's very focused. We know exactly what the needs are, and all we have to do is communicate well enough to understand those needs and build a solution for the needs.
Well, one thing that feels different here, or special here, is that it almost sounds like you are minimizing the amount of change that your end user is going to need to do and making that very explicit. Or well, implicit, but making that a big focus of the project. It's we want to give them as much bang for their buck for the minimal amount of change in how they're doing their existing process, which is not usually how we approach things from generally in data science. Usually we don't even bother thinking about, well, what is the existing process that folks go through. It sounds like, because everybody says that, well, we need to understand the customer and very close to the customer, but here it sounds like a key thing is understanding just how difficult it is for that customer to change an existing process. And so to the degree that you can minimize that amount, the more likely the success of the project is. But it sounds like also potentially also the lower the risk of the project is, because you don't have to change as much. If you change a lot of things simultaneously, who knows what's going to happen. If we are making smaller, more defined tweaks, but using the existing process and the existing controls that are in the process, the likelihood of something going wrong is much smaller. Right.
Absolutely, absolutely. And it doesn't mean that we're going to stop at these little incremental changes. It's just over the years when you start looking, oh, what have I changed over the last several years? It could be a lot. You did it in small steps, so it didn't seem like such an abrupt big change, but you managed to modify the process. And it's funny, we're like having a discussion right now. We were thinking of using generative AI to build like a chatbot that would help our operators, process engineers with manuals, so transform the way that they would interact with manuals, because our manuals would tell you exactly what needs to be done at every step of the process or in every possibility, right? Usually it's a document, and it's some structured are better than others, and some language is clearer than others. And the first use case is, well, let's just go for a chatbot that's going to transform. We just query, take all of this knowledge, right? Build a RAG system and have a chatbot that will allow you to interact it. But the counter to that was, well, our operators are not really experienced with that. It's unlikely they're going to do that. They just want standard. They just want the standard document that has the same format and has the same, the same language and the same order of things. And yes, maybe, and it's probably a simpler thing to do. You probably can work with one document at a time and you fix it. And maybe with the help of generative AI, you take the input and you say, I need a different format, please produce an output for me. Much easier use case. So probably we'll take up that instead of trying to build a chatbot from scratch that would be transform the way the operators work. But once they're used to it, once they see the value, because we will build some features where there will be some chat, but maybe it will still produce the document for them, or maybe it will be a combination of a bot plus a document, right? But on that, you will drive adoption. Adoption is always a challenge, especially the less AI ML literacy there is, the harder the adoption is for these tools, because people are distrustful. They some are scared that AI is going to come to kill us all. Some just don't understand. Like they're really genuinely surprised at the capabilities. I'm like, oh my god, this is revolution. It's a light bulb. I mean, I didn't had no idea. But everybody is resistant to change. I mean, it's part of our human nature. So if you can make the transmission smoother for them, if you acknowledge the challenges that they're facing right now and show them step by step how they're going to operate in the future, it certainly helps. So it's the, I don't know, the product owners or the project leads job to really make sure that the change management does not lag behind this great model that was developed and nobody has to, we don't know where to plug it in.
Indeed. Well, so thinking back as to what the best practices are, it sounds like best practices, to a certain extent, is to align how you deliver value with how you're minimizing risk, and what you're doing on one dimension should be another. So whether it be leveraging people, humans in the loop, whether it be delivering values in stages, going in and minimizing the amount of process redesign that you're imposing on your end users. Those sound like they're key ones. Other ones sound like being able to go in and really understand your data and where signal lives, and change your if any work that you can put in going in and increasing your ability to capture that signal sounds like that would be valuable. Are those the best practices? Are there other best practices that you would add to that list?
Be very data centric. So if you're trying to automate a process, um, you have to, using machine learning, right? Machine learning in the end is just pattern. Right now, they're all pattern recognition systems. Anything from linear regression to all of these large LLMs, they're still pattern recognition systems. So if your pattern doesn't exist in the data, you're not going to capture it no matter how much data you have. So focus on the pattern, and the more important the pattern is that you're trying to capture, the more prominent it should be in your data. So be very mindful when you design your training data sets. I think that's critical for us. It led to a lot of success, but when we really handpicking what data we wanted to, for automation tasks mostly, right? Um, Split up complex projects into smaller ones and try to deliver. Can my initial preliminary analysis or exploratory analysis, is this useful to you? Can I give you some insights into the data that already builds trust? So think of any small part in the process of developing machine learning model AI systems. What along the way can be useful to your end user? It doesn't have to be the full product. So that's also, we found it was very useful to speed things up. We didn't discuss this, but I think it's worthwhile mentioning. We try to build reusable components. So if we access different systems in a certain way, we want to make sure that the way we access it is standardized, the way the login is standardized, the validation is standardized. So we try to pre-build our internal packages that would be reusable. So we spent some effort into building our own internal packages for the way we do things for our ML systems or data pipelines or whatever it is. So we focus on that as well, making these digital assets for ourselves.
Well, thank you, everybody. We now have the opportunity for Q&A. So thank you very much, Desiree and Khan, for submitting your questions. Alex, I think you already responded partially to Desiree, who was asking about education and frameworks for how you go about educating stakeholders. Do you want to quickly summarize that? Because I thought it was an extremely, extremely good answer. I think Alex is still backstage on the platform. Oh, there we are.
Oh, there we go. Sorry about that. Started speaking backstage.
But yes, speaking about education frameworks, and a thing that struck me about your answer there was these discovery sessions, where it sounded like part of the discovery session is you educating the stakeholders on the art of the possible, but part of it sounds like it's a two-way education. It's also you understanding the stakeholder need, the issues, or what data is available, and things like that. Is that the way to think about it?
Yes, absolutely. I think it was primary intent at first to really understand the end user better. That's what the problem solving session was, is our problems and we need end user to help us solve it because we don't understand something. But later on, what turned out to be is that these internal deliberations in front of the end users really help them understand what exactly that we're struggling with when we're building these products. So poor data quality, they can see throughout discussions how it impacts the accuracy of the model, so the final product for them. This is full trust. This is internal discussion, right? They're privy to insider information that you really typically don't want to disclose to your customer how much you're struggling with what you're working on for them, right? But it builds a lot of trust. And at the same time, it educates them. It tells them why is it so important to have good, accurate data, right? It tells them what are the things that we see in the data, what are the questions arise for them, and it shifts perspective for them about what they're doing. And in addition to that, we also get they also hear about the AI models. We discuss about what are we doing, what kind of things we can do, what about other potential use cases from whatever we're trying to develop right now. So they kind of passively, I want to say, absorb all of this. So this is education at the lowest level directly to the end user. At the same time, you want to educate the leaders. It's been said in multiple conferences by multiple leaders across all organizations, if your top level C-level executives are not on board with the development of AI, you're not going to succeed, because it's a big investment. It's investment in time, investment in money, talent, right? So we also try to educate by holding seminars for broader range than just our end users, existing end users. We try to spread it out across organizations. We also try to educate our leaders as well in terms of AR and the art of what's possible.
But it sounds like it's sort of a multi-pronged approach to education. So there's, on the one hand, there's a very high-touch project-based education that's going on, where that's continuous and ongoing. But it sounds like in parallel to this, there is also more of a, for lack of a better term, mass education. So going in and trying to bring up the general level of knowledge and awareness across the broader set of stakeholders. And then yet again, then there's also potentially a more targeted separate training, which is really just for your leadership. And that's probably not standardized. That's probably sitting down with them and giving them almost like individual personalized office hours. Here's everything that you need to know about artificial intelligence that you can ask about without looking silly in front of your peers or the rest of the organization.
Absolutely. Yeah, those are very important, and those can be eye-opening for them. As somebody who day in and day out uses AI or even Copilot on a daily basis, and Copilot's been around for what, almost 2 years now, or more. I lost track already, but you would be surprised how many people are actually not aware, or not aware that our company has it, or that you can use it for something that's useful to them, right? So even the basic things, we're sometimes surprised, like, what do you have to educate your leaders or your people in the organization about AI, because it is a very unfamiliar topic to many.
Yes, I was just at a Harvard Business School event about leading with AI, and you're looking out over a sea of almost close to 1,000 executives, and they asked, well, how many of you have hands-on experience with ChatGPT or any of the Llama 3, Claude, you name it, and the huge numbers of hands go up. How many, and then the next question is, how many of you have spent more than 10 hours with any of these models combined? And then very, very few hands are up there. So in terms of the need and desire of folks at the executive level to go beyond the, okay, I stood it up, I went and asked it a question, but I'm still unclear how I use this as part of my workflow. It seems like there's an opportunity there for that to start that relationship with, let me help you go and use these tools more effectively. And through that education around whether it be Copilot or one of the other generic models, use that as a stepping stone towards further education on the broader AI space. Is there an opportunity there?
I absolutely, and I think it's a must take opportunity, right? If you don't address this, your organization is going to be left behind. Definitely, these one-on-one sessions tailored, especially if you have any examples of how, if there are any success stories, even small, that you can deliver to your leadership and show that, yeah, we can do it. And yes, there are tools outside, and maybe even this is how I use it in my daily work. I personally, when I was coding with all of these open, or the ChatGPT or Copilot or Code Whisperer, whatever it is, my coding productivity increased, I don't know, 400-500%, because it is so useful. So you can use it for anything, and this is where sometimes you have to pitch ideas for them. You can use it to develop a strategy, because these hallucinations, you might give you sometimes something like a unique insight. Oh, this actually might be worthwhile to pursue. So absolutely, you need to educate the leaders, even the people. We were kind of joking around, but it became a serious question. Should we have a mandatory AI awareness training, like our safety training, that everybody has to go through? It doesn't have to be long, but at least get people familiarized with it. It's transformative. It's like bringing a computer into a workplace. Before that, yeah, it's a nice toy, personal computer, but not everybody foresaw how it will transform our work environment. And with AI, I think it's going to be the same.
I imagine it's probably a best practice at this point to have a mandatory AI safety training to get folks to realize just what they might be accidentally disclosing, because we almost all we know that there will be people who are leveraging the non-blessed versions of these models on their personal devices or at home or in other settings, and giving them a sense of, sure, we won't be able to stop you from using them, but let's help ensure that you don't accidentally fall afoul of our data security policies there. But I imagine if you just had that training, it probably would be a little bit tough going. If you combine that also with, and here are also tips and tricks to make your prompts better, and here are some of the ways that you can use in your daily workflows, I'm imagining that they'll be much happier with that training than if it was just the safety training.
For sure. So I have to give props to our InfoSec team. They have delivered already a mandatory training on the dangers of using all these, open source or private, especially private AI models. So that's great. But yeah, it more scares the people away than actually wants them to use it, because everybody's now like, oh, am I even allowed to do that? Right. So this is where the other part of education of what can you do, what tools can you use that are safe and approved. That's also something that we were realizing how important it is, because even for our own team, uh, we had questions in terms of where can we develop and what can we use to develop, because our infosec team did not like some of our initial choices.
They told us what not to do, but they didn't tell us what we should be doing.
Exactly.
There's a great joke that's making the rounds about the data protection officer who used ChatGPT to write the policy that banned the use of ChatGPT.
Yeah, I wouldn't be surprised. Sometimes it sounds like that if you look at all these trainings, that I'm sure they use ChatGPT for that.
Well, we still have time. I did want to get to my apologies. I'm going to mispronounce it. Is it Kang Pham? I was asking about leveraging an AI approach side by side to your existing control system, and so having them running them in parallel. In this case, she was asking, or he or she was asking about doing this as a safety net, so as a control, as a sort of a warning system on top of your existing control system. I'm imagining that's probably not how it's frequently done. It's probably yes, run them in parallel, but use this as a way of seeing the limitations of your existing system and ways in which you can improve that, and getting comfortable with a machine learning or AI based approach to it, and then making that transition. But curious, do you run these systems in parallel?
Yes, but with the reverse effect, right? So this is where we can have a predictive model, so like AI system trying to do predictive process control, um, but because the risks of failure can be catastrophic, we still do not trust them enough. We didn't have built enough trust where they would make the decisions automatically on their own, unless you can build a set of rules that would ensure that you safeguard your system from it. So for now, we always have parallel system, meaning that the initial stages until the end users, and this is specifically for chemical process control, until the end users are really uh, they're really certain that our models perform, as they should. They have a lot of trust in them. We provide our recommendations just as a recommendation for them to accept or not. So they physically have to change the parameters themselves, the settings themselves, until they tell us, you know what, I'm convinced this is safe enough. Now plug into our systems and let's close the loop. But for now, there was just one exception where it happened. It's not happening, and I'm not really surprised. Like, again, I bring up this example of self-driving cars. Everybody said, oh, self-driving cars, we're going to do it so soon, and then these edge cases keep postponing and postponing and postponing, and because safety is so important, you just cannot risk it. So it's still a dream for now.
Well, I imagine, though, you're already getting some of the value because you're probably also providing inputs for improving the business rules system. So you're able to go in and make improvements to your existing process control system based off of insights that you're getting from the model. So that when the models are not in agreement, potentially there are times when the model is right, and then you can encode that into your existing process control system. So that you get the value there, or has that not happened yet?
This is starting to happen, and this is where the feedback, right? So if you look at the prediction, and we always track the predictions, and you see what the output, and sometimes the end user would follow the recommendation. You can feed and improve your model, or vice versa. You can change your process parameters, or you can change your control loop, because we had cases where AI did improve in a control loop, right? So the control loop was too loose. We were wasting too much material where we didn't have to. and we tightened the process window because the predictive model was better than existing process controls, which were derived from statistical process control or design of experiments. So there are improvements on top of that, yes.
Excellent. Well, coming up to the top of the hour, Alex, thank you so much for joining us and for sharing all your insights. If folks want to get in touch with you, I imagine best way to reach out on LinkedIn?
Yes, please. Thank you.
Excellent. And to find out more about Domino, obviously, please go to our website, domino.ai/contact us. I'm happy to continue the conversation. Alex, again, thank you so much. And thank you for everybody for joining us on the webinar and for the excellent questions.
Thank you for having me, Kjell. I appreciate it.